Hi guys, it's Mrs. Anderson. Surprise, your first video made by me. This is going to be the first lesson that we're going to learn about for our logic unit. We're going to be talking today about patterns and conjectures. And I want to start off first with this pattern. And as I write it down, we're not going to have pre-made notes this time, and we most likely will not have them for the rest of the year. I want you guys to start learning how to take your own notes. So in class, I'll be checking them every once in a while to make sure you're on the right track. But I want you to write down this pattern and tell me if you can, well, you can't really tell me, but see if you can figure out the numbers that follow. So 3, 9, 27, 81. What would the next number be in the pattern? So go ahead and pause that, or pause the video and see if you can figure out what the next number would be. So hopefully you notice that between each number you multiplied by 3, and multiplying 81 by 3 would give you the following number in the sequence, which would be 243. This is one type of pattern that we could possibly see. Of course, there's many different options, but in general, you would see patterns with numbers. We could also see patterns with images or shapes. For example, we could have this first shape, a circle with a triangle inside, and then the next thing in the pattern would be a circle with a square inside. The next one would be a circle with a pentagon, and that's not a great pentagon, I apologize. Following that, what would the next term in the pattern be? And then if you wanted to even try to figure out what would the next 15th or 20th or 30th pattern be. You'll notice on this one that we started out with a 3-sided figure, then we moved to a 4-sided, then we moved to a 5-sided, so we went triangle, quadrilateral, pentagon. The following would be a 6, which would be a hexagon, and then following that would be 7, which is heptagon, and so on and so forth. So patterns can be used by using reasoning, and we're using our previous knowledge that we already have when we come to these types of problems to help us solve them. This next sequence that I'm going to write down is one that it would be beneficial for you to become familiar with, especially because on the SAT and ACT, and when you get into more math classes, this sequence is very important. It's very well known. The first few terms are going to be 1, 1, 2, 3, 5, and 8. And I'm going to leave this one blank, and for those of you who can figure out the next 4 terms, please bring them to me in class on Thursday, and we will discuss what this sequence is and why it's so important. There's some vocabulary terms that you need to be familiar with. The first one is conjecture, Conjecture. And a conjecture is what you think might happen or what might be true based on what you have observed. So it's similar to a hypothesis based on information that you've seen, or what you think could possibly happen next would be a conjecture. An example could be that the streets are wet, so I think it has been raining. The sentence, I think that it has been raining, would be my conjecture. The next is a counterexample, and this is spelled Counterexample. A counterexample, and this probably sounds familiar to a lot of you, a counterexample is an example that proves something is incorrect. So for example, all trees lose their leaves in the fall. The counterexample would be that evergreen trees have needles, and they don't lose those in the fall. So I found something that proves that my original statement was not true. That's what a counterexample is. We also have what's called a pattern, and most of us already know what a pattern is, but I'm going to go ahead and give you the definition. A pattern is an arrangement or an ordering. You can extend a pattern if you know the rule for the pattern. And then we have what's called a prediction. Prediction, Predictation. And prediction is similar to a conjecture, but a prediction is something that you think might happen based on what you observe. So prediction, conjecture are very similar to each other. There's going to be a lot of vocabulary terms in these next couple videos that you're going to need to make sure you remember, because the questions are going to ask you to make a conjecture, or they're going to ask you to, for example, in the future, write a conditional statement, or they're going to ask you to write the inverse, or they're going to ask you to write the counterexample, or they're going to ask you to write a biconditional, and you need to know the difference between all of those. So these 4 vocabulary terms that you see written down here are going to be very important for you to remember. We're going to do another example right now, and it's going to be practicing making a conjecture based on information that we have. Okay, so here's an example. I pre-made the example so that way you didn't have to watch me do it all. So you see on this there are 3 different circles. The first circle has 1 diameter, and as you can see on here, it has 1 diameter, but it has 2 regions in it. The second circle has 2 diameters, and it splits this circle into 4 regions. And then the third circle has 3 diameters, and it splits it up into 6 regions. So the question is, what conjecture can you make about the number of regions of a circle that has 20 diameters? So the first question you want to ask yourself is, do you need to really draw a picture with a circle with 20 diameters in it? Is that necessary to do? Or can you come up with some kind of explanation of how you got from 1 to 2, 2 to 4, and 3 to 6, and maybe that will help you find the answer to the question? And so the answer is no. You can solve a simpler problem by finding the number of regions formed by 1, 2, and 3 diameters, and then look for a pattern. So if you look at it, maybe you notice that for the 1 diameter, if I multiply that times 2, I get 2 regions. For the 2 diameters, if I multiply that by 2, I get 4 regions. And then for the 3 diameters, I multiply that by 2 and I get 6 regions. So is that a pattern that seems to be consistent and can be used to find multiple diameters that would be difficult to find if we were to draw it? And how can you test the pattern that you discovered in the first 4 circles before making a conjecture about the 20th circle? Well, if you use the pattern to make a conjecture about a circle with 5 diameters, and then draw the circle in diameters to test it, then you'll find that you'll get 10. If you did 6, you'll get 12, and so on. So you can just keep doing it multiple times, and it'll work out every time. So how is the number of regions of each successive circle related to the number of regions in the previous circle? Well, there are 2 more regions in each circle than in the previous one. So if we did 4 diameters, we would have 8 regions, and that's 2 more than 6. If we had 5 diameters, we would have 10 regions, and that's 2 more than 8, and so on and so forth. So go ahead and write your answer down. If we had 20 regions, I'm sorry, not 20 regions. If we had 20 diameters, 20 diameters, that would give us 40 regions. Let me get that on there. 40 regions. So basically we just made a conjecture, and our conjecture is each circle has twice as many regions as diameters. So 20 diameters form 20 times 2, or 40 regions. Our conjecture is a statement that we can assume based on information that we have. Okay, so the last example we're going to do is finding counterexamples of conjectures. Earlier I gave you the definition of a counterexample. It was an example that proves a conjecture is false. So I have 3 examples here for you that we'll do together, but if you want to challenge yourself, you can pause the video and try them on your own first, and then you can replay or press play and then watch and see if you get the correct answers. The first example says that the first conjecture says if the name of a month begins with the letter J, it is a summer month. So if you think about the different months, in summer, you have June, that starts with a J. If you have July, it starts with a J, and those are summer months. But there's also a month that starts with a J called January, and that month is not during the summer. So our counter example would be January. January is a month in the winter. It starts with a J, so it is a counterexample. Number 2, you can connect any 3 points to make a triangle. Well, I can draw 3 points and connect them and make a triangle. That is a true statement. However, can I take any 3 points and make a triangle? If you recall, earlier in the year we learned a term called collinear. And collinear means points that lie on the same line. So if I were to draw 3 collinear points, would those 3 points, let me make it correct, would those 3 points make a triangle? And you'll find here that the answer is no. These 3 points right here would not make a triangle, and so collinear points could be the perfect counterexample for this question. The last example says that when you multiply a number by 2, the product will be greater than the original number. And I don't know where those 2 extra r's came from, so I apologize. But let's think about it. So 4 times 2, that's 8. 8 is greater than 4. Perfect. 20 times 2. Well, that's 40, and 40 is bigger than 20, so perfect. And if I keep choosing more numbers that are greater than 0, then I would find that every number that I choose greater than 0 would satisfy this conjecture. But what if I chose a negative number? So let's go simple. Negative 1. Negative 1 times 2. Well, that's negative 2. Is negative 2 greater than negative 1? No. What about another negative number? Say negative 10. Is the product of negative 2 and 10 bigger than negative 10? Well, that's negative 20. Is negative 20 greater than negative 10? No, it's not. Would any negative number satisfy this conjecture? Try it. Try a couple larger and smaller than what I chose, negative 1 and negative 10, and see if you find out that the answer to that question is either true or false. Now that you're back, or if you didn't go away, you'll find that all negative numbers do not satisfy this conjecture. So our counterexample would be negative numbers, or numbers less than 0. This is the end of our video today. We'll review over this in the beginning of class tomorrow, and then we'll do some practice over patterns, conjectures, and counterexamples. If you need to come talk to me in the morning because you have some questions, come see me. Otherwise, I'll see you guys in class. Have a good night, and goodbye.